Lattice multiplication is an excellent tool for multiplying any two numbers together. For instance, let's start with 2 times 7, and you probably know this as 14. But let's represent this using lattice. So in order to do that, you would write the first number you're multiplying on the top, and the second number you're multiplying on the side. And then between them, you want to draw a box. And then in the box, you want a diagonal, going from bottom left to upper right. So when you multiply these two numbers together, you want to put the tens digit up here and the ones digit down here. So it would look like this. Here's the 14. And then when you're done filling in all the boxes, in this case there's only one box, you bring all the numbers down this direction. So in other words, since there's only a 4 here, you do a 4 and you bring the 1 down, which would just leave you with a 1. So 14. Simple enough. So let's give a bigger example this time. Let's try another easy one, 10 times 20. And you already know this to be 200, but let's show it using lattice. So yet again, you want to put the first number you're multiplying up here and the second number down here. And they might look spaced, but that's because we're going to input the box again between them. And this time, there's going to be more lines because there are more numbers. So we want to split into 4 boxes attached to each other. And then when we draw the diagonals will go through the adjacent boxes like so. Now, we're going to do the same process again. And think of this as like a multiplication table. You're multiplying this number by this number and put the result of that in this box with tens up here and ones down here. So this would be 2. 1 times 2 is, magically 2. 0 times 2, which is in over here, is just 0. I could also put a 0 up here, and I could put a 0 over here because there is no tens digit, but that just makes everything cluttered. It's unnecessary. Likewise, this whole row down here is going to be 0 because this is 0. So 1 times 0, 0, 0 times 0, 0. And now when we're done, like I had last time, we're going to add these numbers down the diagonals. So it would look like this. 0 is added to itself, you get 0. The two zeros are added to each other, and we get 0. The 2 is added to a 0 and a 0, which we, like I said, neglected to write, so that's just 2. And then there's a 0 here, so we could write 0 there, but it doesn't really matter. So, as we expected, we got the same result. Hallelujah. Now, it gets a little more complicated when these two numbers, when added together, add up to something more than 10. Actually 10 or greater. So let's do another example down here. What if I did 55 times 11? So you might not know what this is right off the bat, but hence lattice multiplication. So we want to write 5, 5, 1, 1, and then draw the box between them. Like I said, make sure it's a bigger box, so we're going to fit more boxes inside of it. And then a line splitting the 5s, and then a line splitting the 1s, and then draw a diagonal. So this is not the prettiest, but I'm also not an artist. So now it's a multiplication table. What is 5 times 1? 5, so put in its respective box. Remember, no tens digit here. Yet again, 5, 5, 5. They're all the same multiplication. So now we're going to add along the diagonals again. But this time, notice that this diagonal here adds up to 10. So let's start with the first one. So I'm sorry, I have to move off to the side a little bit. But the first one is just 5. So we write 5. This next one is ending up being 10. So we're going to take that ones digit and put it up here. And then this will become 0. And then we just add the 5 and the ones digit from the 10, and we get 605. So in other words, every time that a diagonal adds up to something 10 or greater, take all the tens digit and just move it up one diagonal. If this added up to greater than 10, you'd move it up here, and so on. So now it's time for a good larger example. Let's do 1, 2, 3 times 4, 5, 6. And this one, I'm pretty sure that none of us know off the top of our heads. But, yet again, lattice comes in handy. So, we're going to start with 1, 2, 3, and then 4, 5, 6. And now we need to draw a box containing 9 boxes. So here's the larger one, and then inside that one we're going to split the 1 gets its own column, and the 2 and the 3 get their own, and then the 4, 5, and 6 are separated. And then we need to draw the diagonals, like so. And now this is quite easy to do with a pencil when you don't have the fancy line drawings as I do. Same idea, it just looks messier. So now we got 1 times 4, which we will put is just 4. And then we got 2 times 4, so we got 8. And then the last one is 3 times 4, which is 12. So the 2 goes here, and the 1 for the 10s digit goes up there. Now, this row is all multiplied by 5, so 1 times 5, 2 times 5, 10, 3 times 5, 15. And then the last row is all multiplied by 6, so 6, 12, 18. And now, all we do is add along these diagonals again. So 8 is added to itself, so we just get 8. And then 2, 1, 5, which is yet again 8. This one gets a little trickier because this is actually 10, 6 plus 1 plus 1 plus 2. So this will end up being 0, but we will add the 1 up here. So I typically just write it as 1 on the next diagonal, but this diagonal is 0. So now we added the 1 to the next diagonal, so it's 5 plus 1 plus 1 plus 1, 5 plus 1 plus 8 plus 1 plus 1, excuse me. And now we can see here, this is 10, these 3 numbers, and then we're left over with 6. So I'm going to add a 1 up here, I'm going to cancel these 3, and I'm going to put 6, which is remaining. And then the last diagonal is just 4 plus 1, in other words, 5. So the answer to your 1, 2, 3 times 4, 5, 6 is 56,088. In conclusion, Lattice is very useful. Large numbers, small numbers, numbers that you don't know the answer to, numbers that you're just checking, double checking, very easy to do that with Lattice. You're going to end up with a lot of squares and diagonals and a lot of mess on your paper, but it's really useful. It splits stuff into really nice chunks that you can handle piece by piece. So I highly recommend it, and thank you very much.